we've already seen that the tan graph looks like this. The tan graph looks like this, and the inverse tan graph is a reflection along the diagonal line, so it looks like this. So inverse tan looks something like this, which is this line here. And then when you differentiate this, which we've already done, and I'm expecting you to know it, when you differentiate this, it will then give you this thing here. So this graph here is given by this purple line here. So in this video, we're going to come up with the tangent line for the inverse tan graph, and we're going to come up with the tangent line for the derivative graph. So that's this graph here. So let's tackle this line first. So we're going to try and find the tangent line for inverse tan. So we've already seen that when you differentiate inverse tan, it gives you this, and I'm expecting you to already know this because we've already done it. So the equation for the tangent line of the inverse tan graph, which is this line here, well, this is a straight line, so it must take the form y equals mx plus c. It must take the form y equals mx plus c. We need to know the gradient. Well, the gradient is given by, well, when you differentiate this, it gives you this. So the gradient is given by this thing here. But you need to evaluate it. Well, hang on. We know the gradient along anywhere on this inverse tan graph, but we want to know the gradient right at this point here. So hang on, going back down here, we have the ability to work out the gradient anywhere along that inverse tan graph, but we want it specifically at A. So we need to evaluate this at x equals A. So put this into here. So the gradient right here, right at A, is 1 over 1 plus A squared, because you would put this A into the x. So the gradient would be given by this. So this is our gradient right here. Our gradient is there. So now our equation is given by this, but we need to know the intercept. So so going back to here, if you know the gradient right here and you know one specific value on that tangent line, then you should be able to come up with the equation for that tangent line. Well, this location here, hang on, this location here is given by A comma inverse tan of A. So this is your x value, this is your y coordinate, x coordinate, y coordinate of this point here. So now we can put this y into here, and we can put this into the x, just so that we can find C. So putting in there, it will then give us this here. So now you've got one block equals this block plus this block. You want to work out C. So take away the middle block from both sides. That will then give us this. So C equals this block, take away this block. So now that we know C, we can put this whole thing back into the C. So this whole thing here will then become this. So this is our equation of our tangent line for inverse tan of x. Okay, so now let's punch this into Desmos. So jump to Desmos, punch in your inverse tan graph, add your point. So add your point. So this is our point. We can move it back and forth, and then punch in the equation the equation of the tangent line, which we worked out earlier. It was this thing here. So punch that in. Now we can slide back and forth, and then it will give us our tangent line. Okay. So now now consider the other graph. So this graph here is given by y equals 1 over 1 plus x squared. We want to come up with the equation for this tangent line. So we need to know the gradient right here. Well, this is our graph at the moment. If you want to know the gradient, look at dy by dx. So differentiate this. So here you can use any method you want to differentiate this. Let's just use the quotient rule. So imagine this is v, and then imagine this is u. So using the quotient rule, v squared would be this thing squared. So that would be this thing squared. And then the v stays the same. So the v stays the same. And then differentiate the top. When you differentiate 1, it would just give you 0. And then you take away, 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 let me think, differentiate the v. So differentiate this. So when you differentiate this, it will just be 2x. And then leave the top alone. Leave the top alone. So that's this thing here. Oh, by the way, u prime here is actually, when you differentiate 1, it will just become 0. So here you've got 0 times this thing. So this whole thing here disappears, leaving you with this. Well, I'm expecting you to be able to differentiate this by now. So when you differentiate this, it will then give you this thing here. So dy by dx gives us the ability to work out the gradient anywhere along here. But we want to know the gradient specifically at this precise point here, at A. So we need to evaluate this. We need to evaluate this as x equals A. So you've got to put this into here. So that will then give us this thing here. So the gradient at A is given by this. So hang on. So we know the gradient precisely here, and the coordinates for this point here would be A, comma, and remember the equation of this graph is y equals 1 over 1 plus x squared. So the coordinates right here would be A, comma, 1 over 1 plus a squared. So now, so hang on. So the equation for this tangent line, well, it's a straight line, so it's going to be y equals mx plus c. We know the gradient right here, which we just worked it out earlier. The gradient was this thing here, so we can put this into the m. So that will then give us this thing here, and then x, and then plus c. So now, now we need to work out c. Hang on, let me clear this up. So now we need to work out c. Working out c, hang on. We know the gradient. We know the gradient's right here, and we know the precise location. So now we should be able to work out the equation of that line. So so now put this. This is our x value here. So put it into the x. Put this into the y. We already know the gradient, so therefore we can work out c. Well, that will then take us to. That will then take us to here. So now you've got one block equals this block plus c. So add this middle block to both sides. So c equals this whole thing here. So you can put this back into the c here. So the equation of our tangent line is given by this. So now jump to Desmos and punch this in. So jump to Desmos, punch in our equation. Punch in our graph, 1 over 1 plus x squared, and then punch in our point. This is our point here, so we can slide a back and forth, and then punch in our equation for the tangent line. So this is our equation for the tangent line, and then as you slide a back and forth, it will draw your tangent line. Okay, so play around with Desmos. So that's our answer. Okay.